Okay, guys, let's check our answers for the uh, experimental and theoretical probability day one questions. Question number one, the outcomes of specific events, they are D, favorable outcomes, meaning what would be the probability of flipping a coin and getting heads, right? The total number of outcomes would be 2, but your favorable outcomes would be 1, right? The specific event would be getting heads, right? So 1 is D. Question 2, an investigation or procedure that has varying results, right? That's an experiment, A. Question 3, the possible results of an experiment. Those are your outcomes, B. Question 4, a collection of one or more outcomes of an experiment. Question 4 should be, let's see, that should be C, event. Question 5, a number from 0 to 1 that measures the likelihood that an event will occur. That is E, probability. Question 6, probability that is based on repeated trials of an experiment. That is A, experimental probability. Question 7, the ratio of the number of favorable outcomes to the number of possible outcomes when all possible outcomes are equally likely. That is answer B, theoretical probability. Question 8, the fraction or percent of the time that an event occurs in an experiment. That is letter F. That is relative frequency. All right, that's the end of the vocabulary. Question 9, you roll a number cube. Determine the theoretical probability of the event. Well, the event number 9, the probability of rolling a 3, the theoretical probability of rolling a 3, well, there are 6 possible outcomes on the number cube. Rolling a 3 is your favorable outcome, and there's only one 3 on the 6-sided number cube, so the probability would be A, 1 out of 6 for rolling a 3. What about rolling an 8? Well, out of the 6 possible outcomes for rolling a number cube, there are 0 8s on a number cube, so the probability would be C, 0. Question 11, rolling a multiple of 2. Well, what are your multiples of 2 on a number cube? Well, that means you could roll a 2, you could roll a 4, or you could roll a 6. Those are your multiples of 2 on a number cube. So out of the 6 possible outcomes on a number cube, 3 of those 6 outcomes are multiples of 2. And 3 out of 6 would simplify to C, 1 out of 2. Question 12, rolling a number less than 6. Well, what are the outcomes that are less than 6? Well, you could roll a 1, a 2, a 3, a 4, or a 5 on a number cube, right? So rolling a number less than 6, that would have to be D, because 5 out of the 6 outcomes are less than 6. All right, so that would be D. All right, but what about rolling a 6? Well, if you roll a 6, right, this says less than 6, so there'd be 5 of the 6 outcomes. All right, question 13. A bag contains 50 marbles. The theoretical probability of drawing a purple marble is given. Find the number of purple marbles in a bag. Well, if the probability of pulling a purple marble is 1 out of 10, right, that's the probability that's given, and we're saying there are 50 marbles in the bag, right, we could set up a proportion to find the number of purple marbles in the bag, right? So our variable would be n. We know how to cross multiply and divide, right? So we cross multiply, right? We'd get 10n is equal to 50, and then we would divide both sides by 10, divide both sides by 10, and we would get n is equal to 5, right? N is equal to 5, and that would be answer B for number 13. Or you could just say 1 over 10 is equal to 5 out of 50. Question 14, we start off with that same fraction. 4 out of 5 is equal to how many out of 50? Well, let's do this problem instead of writing and solving a proportion. Let's use equal fractions here, right? So we could just say 5 times 10 is 50, so we can make an equal fraction. 4 times 10 is 40. So the correct answer for 14 would have to be B, 40 out of 50, right? We could have written a proportion and solved it like we did for problem 13, but you could also do the problem using equal fractions as well. Okay, question 15. It says, the bar graph shows the results of spinning the spinner 40 times. Find the experimental probability of the event. Okay, well, let's take a look at that. Here's your spinner, right? We have 1, 2, 3, 4, 5 different sections on the spinner. This bar graph here, right, that shows the results of spinning the spinner 40 times. We want to find the probability of spinning a 3. Well, here's your 3's, right? And it says, what's that, 10 and 12, that's 11 out of the 40, right? 11 times out of the 40 times that it's spun, right? Because it says 40 times up there, and there are 11 out of the 40 were 3's, so that should be answer C for number 15, right? Just by reading the bar graph that shows the experimental probability of the event, which means that you actually took this spinner and spun it 40 times. And this bar graph shows the outcomes for the 40 spins of that spinner. Okay, let's try another one. What's the probability of spinning a number greater than 4? Right, the experimental probability. Well, a number greater than 4, well, the only number on the spinner that's greater than 4 is your 5. So we want to find out how many times a 5 was spun, and that looks like that was 7, right? So it looks like then that should be 7 out of the 40 spins, right, were 5's. So that would be...
I can learn to understand you much better if I can get some...
That would be, let's see, answer D. Let's see, okay. Next question, question 17. Had my, whatever, computer jump in the middle of that. That's funny. Okay, question 17. Spinning a number less than 5. Less than 5. Well, a 4, a 3, a 2, and a 1 are all less than 5. So we have to find how many each of these were spun. So it looks like 10, 12, that was 11, this was 11, this is 11, and this is 4. So 11 times 3 is 33, and 4 is 37. So it looks like 37 out of the 40 spins were less than 5, and that would be answer A for question 17. Question 18, spinning a 3 or 4. So I look at my graph, my bar graph that shows the outcomes for my experiment, and I'm looking for the 3 and the 4. Right? So it looks like this is 8, that's 9 times, this is 2 times, so it looks like a total of 11 out of the 40 times we spun a 3 or a 4. So for 18, that should be answer D. All right. Question 19. use the spinner to determine the theoretical probability of the event. All right. So for those last few problems, we were looking at bar graphs that showed the results of an experiment. Now we're looking at a spinner, and we want to know the theoretical probability for the spinner. Well, if we look at our spinner, that looks like there's 1, 2, 3, 4, 5, 6, 7, 8 equal sections on our spinner. Okay. So the probability of spinning a 4 out of the 8 sections, only one of the sections, right, is a 4, right, just that one there. So for question 19, that would have to be letter A, 1 out of 8. Question 20, spinning a number less than 5. Well, what's less than 5? Well, 4, 3, 2, and 1 are all less than 5. So out of the 8 possible outcomes of the spinner, 4 of the 8 outcomes are less than 5. 4 out of 8 would simplify to answer D for question 20, 1 out of 2. Okay. Question 21, spinning a number less than 12. Well, when we look at our spinner, all 8 outcomes are less than 12. So out of the 8 outcomes, all 8 outcomes are less than 12. So for question 21, that would be a probability of 1, or 100%, because all of the outcomes are less than 12. Problem 22, spinning an odd number. Well, let's look back at our spinner. 1, 3, 5, and 7 are your odd numbers on the spinner. So we have 4 of the 8 outcomes, right? 4 of the 8 outcomes are odd numbers. So once again, that's going to be B, right? 1/2 for question 22. Question 23, spinning an even number. Well, if we look at our even numbers here, our even numbers are 2, 4, 6, and 8. So for even numbers, there are also 4 out of the 8 outcomes that are even, and that would simplify to answer D, 1 out of 2. Question 24, spinning a multiple of 2. Well, when we look at our spinner, our multiples of 2 are also going to be our even numbers. So we have 2, 4, 6, and 8 are our multiples of 2. So out of the 8 possible outcomes, 4 of the 8 outcomes are multiples of 2. So for question 24, we should have answer D, 1/2. Question 25, spinning a multiple of 3. So I have to go back to my spinner, spinning a multiple of 3. Well, 3 and 6 are your only multiples of 3. So out of the 8 possible outcomes, 2 of those outcomes are multiples of 3. So 2 out of 8 would simplify to 1/4, which is answer C. Question 26 asks for the theoretical probability of spinning a multiple of 4. Well, so I come back here. My multiples of 4 are going to be just 4 and 8 are your multiples of 4. So once again, out of our 8 possible outcomes, 2 of those outcomes are multiples of 4, and 2 out of 8 would simplify to answer B, 1 out of 4. All right, let's look at question 27. You shuffle a deck of 26 cards representing the letters of the alphabet. You randomly select a card from the deck. What's the theoretical probability that the card represents one of the letters shown in the word touchdown? All right. Well, we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 letters in the word touchdown. But some of those letters repeat. Let's see, does T repeat? No. So what do we have? We have T's. That's one letter. We have O's, but there's a couple of those. We have a U. We have a C. We have an H. We have a D. The O repeats. Right? We have a W, and we have an N. So out of those 26 cards, we have 1, 2, 3, 4, 5, 6, 7, 8. Right? So we have 8 out of the 26 cards would have letters from the word touchdown. 8 out of 26 would simplify to letter B. 4 out of 13 for question 27. Question 28. There are 16 sixth graders, 11 seventh graders, and 9 eighth graders in a gym class. The gym teacher randomly selects one student to collect balls. How many ways can choosing not a seventh grader occur? Well, there's 16 and 11 is 27 and 9, so there are 36 possible outcomes. But how many ways are there not a seventh grader? Well, there's 16 not seventh graders here. There's 9 not seventh graders there. So 16 and 9, there'd be 25 ways that you could choose not a seventh grader. Question 29. A bag contains 50 marbles. The theoretical probability of randomly drawing a purple marble is given. Find the number of purple marbles in the bag. All right, we did one of these as a multiple choice item, right? But now we're doing this as not a multiple choice. So if 9 marbles out of 10 are purple, how many marbles out of 50? Right? So we'll write and solve our proportion or use equivalent fractions. Either way, you're going to get n is equal to 45 purple marbles for question 29. Question 30. You're playing a baseball board game. You determine the results of an at-bat by drawing a card from a stack. The theoretical probability of drawing a base hit is 1 out of 3. If there are 18 cards in the stack, how many cards represent a base hit? Well, if 1 out of every 3 cards represents a base hit, and there are a total of 18 cards in the stack, how many cards represent a base hit? Right? We can set up a proportion, right? And we can write and solve. So you could either cross multiply and divide here. 3 times n is 3n. 18 times 1 is 18. And then we would divide both sides by 3. And n is equal to 6 for question 30. Question 31. There are 98 letters in a board game. You randomly select or draw tiles that are shown. How many of the 98 letter tiles would you expect to be vowels? Well, we drew 1, 2, 3, 4, 5, 6. We drew 7 tiles. And out of the 7 tiles, how many were vowels? 1, 2, 3, 4. So we had 4 out of the 7 tiles were vowels. Well, if we have a total of 98 letter tiles, once again, we could set up a proportion to find out how many out of the 98 would be vowels. So we cross multiply and divide. 7 times n is 7n. 4 times 98 is 300, what's that, 92. And we would divide by 7, they cancel. And so n is going to be equal to, what's that, 7 times 5, 56. N is going to be equal to 56 vowels, right, we would be able to expect. Okay, question 32. The bar graph shows the results of spinning a spinner 200 times. Compare the theoretical and experimental probabilities of the event. All right, well, let's start with the experimental, right? The probability, right, the experimental probability of spinning a 5, okay? Well, there's 1 5 out of the 5 possible outcomes. So that's going to be 1/5 would be the experimental probability of spinning a 5. What's the probability theoretical of spinning a 5? Well, it looks like that was 43, right? 43 out of the 200 times that the spinner was spun. So you're asked to compare, and anytime you're asked to compare amounts in a math class, you always want to use greater than, less than, or equal to. Well, 43 out of 200 is a little bit more than 1/5, but they are approximately equal. All right, so your theoretical probability is approximately equal to your experimental probability in this first case, because 43 out of 200 is very, very close to 1/5. All right, and let's do the same thing for our next problem here. Spinning a number greater than 2. Well, what are your outcomes greater than 2? Well, you have a 3, a 4, and a 5. So your experimental probability of spinning a number greater than 2 is 3 out of 5, right? Which is about 60%, or is 60%. What is the experimental? I'm sorry, oops, I wrote that wrong. This is your theoretical probability here, right? Your experimental, we have to look at the results of the experiment from the bar graph. And the experimental probability of spinning a number greater than 2, so that's going to be 40, 37, and 38. We add all of that up, and that's going to be 115 out of the 200 spins. Well, 115 out of 200, once again, is very close to the 3/5. So they are about equal, right? So your probability experimental is about equal to your theoretical probability, because they're very, very, very close. All right? Okay, hopefully that's been helpful, and good luck with the next day's problems.